Imagine going weeks or even months without any human contact, no conversations, no texting, no hugs, no shared experiences, just silence and isolation. How would your brain cope with that? More than just loneliness or boredom, your brain actually undergoes profound changes at the cellular and structural levels that affect how you think, feel, and behave. In this video, we'll explore the fascinating neuroscience of social isolation, its impact on cognition, emotion, brain structure, risk of disease, and the hopeful possibilities of recovery. Humans are inherently social creatures. Our brains evolved in complex social environments where interacting with others was crucial for survival. Social connection is actually a biological need, similar to hunger or sleep. Without it, the brain's balance is disrupted. Neuroscientists describe this as social homeostasis, the brain's effort to maintain a set point of social contact. When isolated, certain neurons in brain regions linked to reward and motivation become hyperactive or overly sensitive, as if the brain is craving those missing inputs intensely. Yet paradoxically, prolonged isolation may lead to withdrawal, because these social circuits get downregulated when connection efforts repeatedly fail. This complex feedback loop means the longer someone stays isolated, the harder it becomes to reconnect, both emotionally and neurologically. One of the most subtle but pervasive impacts of social isolation is on cognitive function. Studies show that people who are socially isolated experience declines in memory, attention, processing speed, and executive functions such as decision-making and planning. In fact, the cognitive decline associated with long-term isolation can be comparable to the effects of aging or early stages of dementia. Why does this happen? Social interaction stimulates the brain in diverse ways. It requires language processing, empathy, problem-solving, and emotional regulation. Without these brain exercises, neural connections weaken. Synapses, the communication points between neurons, become less dense, especially in the hippocampus, the brain's memory center. Animal studies reinforce this, where isolated rodents show reduced neurogenesis and poorer performance on memory tasks. MRI and brain imaging research reveal that chronic social isolation can literally shrink certain brain areas. The hippocampus and cerebral cortex, key regions for learning, memory, and emotional processing, show reduced volume in people experiencing prolonged loneliness or isolation. In addition, the prefrontal cortex, which governs complex thinking and emotional regulation, exhibits thinning and reduced gray matter density. White matter integrity, the connective highways that enable communication between brain regions, also deteriorates, further impairing cognitive function. These structural changes aren't just markers of aging or illness. They reflect how critical social stimulation is for maintaining brain health. Social isolation is strongly linked to increased risks of depression, anxiety, and stress disorders. The isolated brain exhibits altered neural activity in regions like the amygdala, which processes emotions such as fear and threat. Without regular social cues and support, the amygdala becomes hypervigilant, causing heightened stress responses and emotional instability. People feel lonelier, more anxious, and less trusting of others, creating a vicious cycle that deepens isolation. Sleep disturbances are common, further impairing mental and physical health. Physiologically, social isolation can disrupt hormone levels, for example, increasing cortisol, the stress hormone, and decreasing oxytocin, the bonding hormone, leading to inflammation and immune system weakening. The statistics are striking. Social isolation increases the risk of developing dementia by up to 40%. It's also associated with higher rates of cardiovascular disease, weakened immune function, and even premature mortality. The exact mechanisms are still being studied, but it likely involves a combination of chronic stress, brain shrinkage, and reduced cognitive engagement. Social isolation accelerates brain aging and exacerbates neurodegenerative processes, causing earlier or more severe cognitive decline. At the microscopic level, isolation changes gene expression related to inflammation, synaptic plasticity, and myelination. In animal models, social isolation disrupts the development and maturation of oligodendrocytes, cells essential for healthy myelin production. This leads to impaired neural circuit function. Isolation also alters neurotransmitter systems, including dopamine and serotonin pathways, which regulate mood and motivation. Immune cells in the brain, like microglia and astrocytes, become overactive or dysfunctional, contributing to neuroinflammation, a factor implicated in depression and cognitive decline. These biological changes can persist long after isolation ends, but the brain also shows remarkable capacity for repair. The good news is that many of these effects are at least partly reversible. Neuroplasticity, the brain's ability to rewire itself, means that reconnecting socially, learning new skills, practicing empathy, and engaging in stimulating activities can rebuild neural connections. Research in both humans and animals shows that resocialization can restore cognitive function, reduce anxiety and depression, and even reverse brain volume loss. Simple acts like conversations, group activities, volunteer work, and hobbies stimulate the brain's social circuits. Mental health interventions and community programs targeting loneliness are increasingly recognized as crucial public health tools. To sum up, social contact is not just a source of joy. It is a fundamental human necessity that shapes our brain's structure, function, and resilience. Prolonged social isolation triggers a cascade of changes that affect cognition, emotion, and long-term brain health. But recovery is possible, so the next time you feel distant or disconnected, reach out. A simple hello or a shared moment might be the most important thing you do for your brain's health, because ultimately, our brains are wired for connection.